let's get started with the book. And so you just told me that there is a bit of a story to this title, especially like you meant the upper part here, right?
A little bit of exactly. So the first blue lines are essentially my work. So what you see in those lines is the first line is the C++ code that most people would write. And then the second line is what is produced by something like Clang. So this is the LLVM intermediate representation. And that's essentially where the work of the backend engineer starts. And what you see in the line below is another intermediate representation that is used in LLVM, which is the machine intermediate representation. And this one is target specific. So meaning that what you see on that line, so a bunch of variable with the percent sign, but the interesting part is the opcode, the add WRI. So this is an opcode that's specific to AR64, for instance. And then the next line is the assembly code that you would get with such representation after register allocation. So W0 is your register for your target. So again, we're talking about low level stuff here, like you're tapping into the right registers and the right memory space and all that stuff. And then the last line, the hexadecimal sequence, is actually the encoding for the machine so that it can execute this addition. So it's I thought it was maybe not clever, but a nice touch that if you know what you're looking at, it's real. But if you don't know what this is, it just passes over your head and it's like, yeah, some stuff there.
Yeah, and it's actually also made it to the printed book, which I got yesterday. So one of the rare interviews where I actually do also have the printed version. The ebook has the advantage that it's not that heavy. So when we go into
the advantage is that you could use it to
more than 500 pages. So this is really going in depth with LLVM. So let's take a look at the ebook itself. Let me just scroll out a little bit for that. And then let us
just to comment on the size of the book, the
yes
reason it's so big is that so the main goal of that book is if you ever work with LLVM, there's essentially two parts in LLVM. So it's kind of weird in a sense when you're not familiar with compilers. But when you look at a compiler like Clang, there is the front-end part that is responsible of taking your C++ code and producing this LLVM IR. And when you have the LLVM IR, that's when you are into the backend code. Now, actually, when you zoom into the backend, there's several parts in there, and there's a part that we call the middle end and a part that we call the backend. So it gets confusing because the backend has a backend. But anyway, so the bottom line is that the middle end is very well documented in LLVM. It's the LLVM IR that is used pretty much everywhere, like pretty much every language is lower to LLVM IR, and that part is very well documented, and you know how to write optimization and stuff like that. But the second part, the backend part, is has very little documentation, and I in that book I have to document that part. Essentially, that's the main goal of the book, documenting the backend part of the backend. But it wouldn't be a real LLVM book if I didn't also talk about the middle end part. So there's actually a good chunk of the book that is about the LLVM IR part, because if you don't know the LLVM IR part, you actually cannot work on the backend part. So when you put all those things together, it's really like from right out in the front end all the way down to the assembly code, there's a lot of ground to cover.
Yeah, and LLVM is quite a big project, so let's see what the book covers. Project, yes. So the first chapter, it's like not very surprising. We're starting with basically what LLVM is and getting started, and all that is what you just talked about. The various also, the infrastructure which LLVM runs on, like the build system. Nowadays, LLVM is built with Clang, and maybe let's just have a look at that whole chapter a bit. So this is just really the tools LLVM uses, right? There's Git, there's C++, of course.
Exactly, yes.
CMake,
Ninja,
and Python.
Projects, so you need all those tools. Correct, yeah.
And then basically LLVM is mostly implemented in C++ as far as I know.
That's correct, yes.
Can you tell me something about what C++ standard does LLVM use?
So that's a good question. I don't remember if we are still on C++ 17 or if we switched to C++ 20. Essentially, we bumped the LLVM. So that one of the nice things about the LLVM code base is that the community tries to keep it fresh and adopt new language features to make sure that whenever there's new people that want to enter into the project that can use whatever is the most advanced feature, as opposed to having to restrain themselves with, I guess, things that are maybe not so well taught in school and stuff like that. So that's not like a free thing, as in every time we bump the C++ version, that means that there are some tool chain that we won't support anymore. Like you need to bump your Visual Studio compiler that is supported by LLVM, Clang, and all that stuff. So we need to make a conscious decision that when we bump the standard version that we use, it may potentially push out some developers from the project, but also allow new developers to come in.
Yeah, that's like the second chapter is already then, so first is basically what setup you need, and then in the book, you're directly focusing on actually getting folks up to speed to contribute to LLVM.
Absolutely. So one of essentially the first chapter is about like how do you get your environment set up so that you know how to build LLVM essentially, and then down the road being able to modify it. And the second chapter is about something that, so I guess let me step back a little bit to give a little bit more context on the book itself. So I've been working at Apple, Google, and Meta, and I've been onboarding a lot of new hire on LLVM. And essentially that book is also the synthesis of these tens of years of experience with onboarding people, and I'm trying to address the questions that came often. And one of them is, okay, I know how to build LLVM and do things with LLVM, but how do I give back to the community, or how do I be part of the community? And what I wanted to highlight in the second chapter is that contributing to an open source project, and that's not specific to LLVM, is more than just writing code. You can help by reporting issues, you can help by helping reviewing patches, benchmarking things, participating in design discussion and all that stuff. And I'm covering essentially those things, and also ultimately contributing code, so that essentially people feel more familiar about, okay, how do I get started, and it feels like less scary in a sense. Like you have to remember that every contributor in LLVM or any open source project was an outsider at some point, me included.
Yeah.
So what I'm saying is that with enough time, that can be you. You could be the next key contributor in LLVM. I'm not saying I'm a key contributor, but I'm saying it's possible to get there.
Yeah, I think that's definitely something which we want to have, and we need more implementers for our infrastructure generally, be it LLVM, be it Clang itself, be it other projects.
Absolutely, and I think there's one of the mistakes that a lot of people make when they think that contributing to open source is about patches, is that for a community to work well, is that you need actually more people that review patches than people that produce patches. So if you have a big imbalance with respect to who's contributing versus who is reviewing, either your code quality is going to go down, or there's a huge bottleneck on the reviewing, and then your project is kind of moving at a slow pace. So what I'm saying is that reviewing is super important.
Yeah. And then you continue in chapter 3 about compiler basics and how they map to LLVM APIs.
Correct. So that chapter is really about giving you the fundamentals about how to get started with a backend compiler. Things like what is a control flow graph, what is a basic block. So if you've never worked on a compiler, those terms may not be familiar to you, and essentially I'm covering that in that chapter.
Mm-hmm.
So it's very down to the earth type of explanation. I'm not talking about mathematic formulation like that. There's a lot of books on that, and they do a better job than I do for those things. But I also feel that they are kind of hard to grasp when you're coming from I would say more practical background. So what I'm saying is that it's probably not the best scientific definitions that you would find out there, but it's probably the most useful one, if I may say. So here we talk about targets. So what is your target, your host? What does it mean to lower something? What is a module, a basic block, and all that thing. So essentially all the concepts that you will see that translate into C++ classes when you work with LLVM. And I felt it was important to introduce them so that you know when you're, for instance, working with the function class, you know what type of object you're dealing with.
Mm-hmm. And then you continue with basically starting on optimizations.
Yeah.
In chapter 4.
That's why it gets interesting. So the 3 first chapter are, would say, more easy into going into LLVM, and then the 4th chapter is really about, okay, now you kind of know the basics. Let's put that into practice and let's try to write your first optimization. So that's why I introduce more of the APIs that are used to write an optimization, but also some of the concepts that are specific to optimization, like what is legal, like when you look from a C++ semantic, for instance, things, is it okay to replace a multiplication from floating point by like a different operation, or like a power operation with a multiplication, or things like that. So things that would make your architectures or your program in the end go faster, but that you need to make sure that you preserve the semantic of the input program.
That's true.
So yeah, because it's easy to have things go fast, but also to break the semantic of the program, and at this point it's kind of pointless.
So this was chapter 4. Now we go into like things which are now, I think now we dive more into the world of LLVM, right? With pass managers. What's the pass manager?
So pass manager, the way LLVM is structured is a very modular compiler. The idea is that every optimization that you do can be actually be extracted in its own library. So there's when you think about the compiler pipeline to go all the way down to assembly, it's essentially a sequence of optimization that you put next to each other. And what the path manager is responsible for is making sure that that sequence of optimization, well, first of all, build that sequence of optimization based on whatever requirement you have. For instance, when you compile your program with O0, the sequence of optimization is not going to be the same as if you compile with O3. There's different things that you do, like, for instance, auto vectorization and this kind of things wouldn't be part of the O0 pipeline. So that is the first responsibility of the path manager. And the second responsibility of the path manager is that each of those optimizations uses some utilities that are provided by LLVM, and those utilities like compute some property about the program that you're transforming. And the path manager maintains this information on the side and make sure it's recomputed dynamically when you need it for your path, if it's invalidated by another path and things like that. So essentially, it's doing all the heavy lifting of making sure whatever you see in your optimization is fresh, and making sure that your optimization is running when you say you wanted it to run.
Okay. Let me go back in the index. Then we go really deep with TableGen, right? Chapter 6.
TableGen. Yeah, TableGen is an interesting one. So TableGen, it comes from Table Generation, and essentially this is a domain-specific language that has been introduced in LLVM that we use to describe some properties about the target or about different things in the compiler. So, for instance, all the options that you see in Clang are described in TableGen, as opposed to writing a bunch of boilerplate code for all the command line options. We have declarative DSL to map all those options directly. It's yet another thing to learn when you work with LLVM, but it's a kind of necessary evil because it is much denser than C++ in that front. Now, the thing that gets tricky is that TableGen is a language like C++, but then there's the way the language is interpreted depends on what you do with it. And in particular, the same DSL is used for like your command line option description, but also to describe all the intrinsics that you can see in C++. So meaning this really target specific low-level function calls that you would insert in your C++ program to use really specialized instruction of your architecture. So all that stuff is actually represented in the same DSL. And as you would expect, the way you interpret your TableGen description for your command line option is completely different of how you interpret your intrinsics definition. And I'm essentially trying to explain those differences in that chapter, and also how to approach a specific description in TableGen when you haven't seen it ever. Like, essentially, how do you find the information that tells you how to use that specific thing? So that's kind of a sore point for a lot of developers. So it's a very important chapter. I don't know how good of a job I made because it hasn't landed in the reader's hand yet. But I'm hoping it would help clear a lot of the difficulties around that DSM at least.
Yeah. So let's look at the next chapter for the book. And we've seen the chapter 6, and now we go into the second part of the book where we now actually dive deeper into LLVR. And now we learn a bit about the AR. So that should be around 200. There we are. So we probably, this is a really important chapter, I think, which we have reached now. People need to understand that there is an intermediate representation. I think that's what's IR standing for, right? If I remember that correctly.
Exactly. Correct. Yes. Yeah.
So
this is essentially what all the front end that use LLVM produces. So Clang produce LLVM IR, Rust produce LLVM IR, Swift produce LLVM IR, and then you can look at other stuff like MLIR. So I guess so some ML related stuff produce LLVM IR. So essentially everything that wants to use LLVM as a backend needs to produce LLVM IR. So it's kind of this funnel that is common across a bunch of different languages and type of applications, and that is the archstone of LLVM infrastructure. It's really how you enter in a way into the LLVM ecosystem. And that chapter is about understanding how this IR is structured and how you manipulate it, essentially.
Yeah. I quickly had to post the link to the book. So this is a book which is especially about LLVM and code generation, specifically about the inner workings, which we now have reached, basically. The first chapters give you an overview how to get started and are more general and gets people some knowledge which is not necessarily only needed for building LLVM, but also is like, of course, using LLVM as an example. But if we look now at the next chapters, the second part of the book is now we've been here. Now we go into chapter 8 with survey of existing passes. Now we basically get a bit of learning about the infrastructure of LLVM, if I see this right?
That's correct, yeah. Essentially what exists there so that you don't have to re-implement it. Like, here is the power that LLVM gives you, and instead of re-implementing stuff, here's how you use it. And the idea of this chapter is really to give you an overview of everything that's available for the middleman. So again, the LLVM intermediate representation to LLVM intermediate representation transformations. And we go through all those things, and I give some tips on how you find the different optimizations that are available, and how essentially what they do with small examples, so that you can decide when you build your own pipeline of optimization which one you may want to use. So LLVM comes with a predefined default pipeline for optimizing or lowering, I guess, code with like a different pipeline for, again, O0 versus O3, for instance. But that chapter gives you some ideas how the type of things that happen and how you can tweak that things and by inserting whatever you want.
And then target-specific constructs is in the introduction in the next chapter, which...
Correct, yeah. So that's where we start to talk about things like intrinsics, like how you expose intrinsic in C++, for instance. So those magic function that will allow you to tap right into the power of your architecture from the C++ level. So of course you can use inline assembly for the purist, I guess, but intrinsic are kind of in the middle, where at least you give some knowledge to the compiler of what's happening here. So that chapter covers this type of things, like again, intrinsics, but also things that are specific to the architecture, like how pointers are aligned, like what size of the address, like is it a 32-bit address space, is it a 64-bit address space? So things that are important when you do pointer arithmetic in your C++ program. LLVM needs to know about those things to be able to do the right thing and being able to prove some things one way or another. Like, again, this notion of, is it legal to transform my program one way or another to make it run super fast? And we need a bunch of information on the target itself to know what you can or cannot do. And that chapter covers all this information.
Then we jumped ahead of it, but the next chapter, the chapter 10, is hands-on debugging with LLVM IR passes.
Yeah, so that one is really about, okay, now you kind of start to know how to work with LLVM. Let's say that a lot of people don't know how to use a debugger. So the idea was, in that chapter, here are the tools that you can use to debug your passes. So LLVM comes with a bunch of logging mechanism that you can use to see the intermediate representation after seeing the lowering pipeline. So the intermediate representation after different optimization phases. So you can see if the intermediate representation lowers the way you want, I would say. But also in that chapter, I also cover the basics for how you debug LLVM with a debugger, which functions in the LLVM API that you can call from the debugger to kind of inspect the state of the compiler. So all in all, that chapter is really about tips and tricks of understanding what's happening under the hood.
Yeah.
And of course,
so
instrument your code.
And I guess when you work on compiler infrastructure, that is really important that you're able to use the debugger which comes with your compiler, and especially to understand its features to show you the IR and other states.
Yeah. Absolutely, yes. Yeah.
And
but for instance, if you see just this one command line, that's a tool that's super important as a compiler backend engineer. That one command line, for instance, allows to extract a specific piece of your program into a smaller file, so that when you try to reproduce a problem with the compiler, you can just look at this one small function as opposed to your gigantic C++ file. So in that case, we extract two functions, bar and foo, and put that in so from the input.ll file, which is the extension file for LLVM intermediate representation, and we print that on the standard output.
Let's look at the next chapter. We were at 10, now we're going and getting started with the backend.
So
this is now basically
backend of the backend.
Yes, we are now really, really deep inside the compiling mechanism, right? So we are leaving behind everything that has to do with C++. This is still implemented in C++, but let me guess the number, 345. Yeah, here we are, getting started with the backend. And so now the backend is basically what produces the output for the assembler, right?
Correct. Yeah.
And
so the backend part is responsible for taking the LLVM IR that has been optimized by the middle end, and then produce the assembly code. And that part in LLVM actually used a different intermediate representation that is called the machine IR, and it's really target specific at this point, meaning that all the opcodes that you will see, so the elemental operation that you can use in a way, are specific to your architecture. So if I compile for x86, I would get different opcodes than if I compile for AR64, for instance. And that in that sense, so that that intermediate representation is target specific, but what this chapter explains is that there are still like an overall structure that is the same for all the targets, and what changes essentially how the register file are described and the opcodes and stuff like that.
As this graphic shows, basically the backend starts when we have transformed the C++ from the front end into the intermediate representation, which is blown up language inside of Clang, or like just a format to represent what the C++ code like would mean, and then now it gets in the backend, which has like the middle end, or like the pre-step before we then actually have the instruction selection, which then goes into the machine representation and then the assembler. And I think this shows very good here in this graphic. And then
so LLVM has a nice way. Yeah, so this is specific to LLVM. That's the serialization format for the machine IR, and it's kind of YAML based. If people are familiar with the YAML format. But yeah, essentially here I'm explaining how you read that stuff and how you interpret it and how you can play with it to even when you want to reproduce bugs and or test some things.
Okay, and now I see Nick doing stuff like mapping the mir file to the C++ API. But now we're really deep into basically this is stuff you work on when you want to write a new backend, a new module for LLVM, which translates to like a new assembler or a new machine platform when you have like an embedded device where you want to run your code on now.
Absolutely.
And I think that's one of the things you worked on. You said on the beginning that for various companies.
Absolutely.
And then chapter 12, we're going into the getting started with the machine code layer.
So the machine code layer is yet another intermediate representation in LLVM that is used at the very end of the pipeline. It's essentially the abstraction that hold all the information about the encodings of your targets. So, encodings and assembly. So, meaning how you print your strings for your C++ toolchain for the assembler for this particular target, and how you each instruction is encoded in binary format in the end, and the binary format also depends on the OS, like the way the binary file is structured is different if you run on Windows or if you run on Linux or if you run on macOS or iOS and stuff like that. So here I introduce all that because that impacts the way you model your architecture in LLVM. So again, very low level stuff. It's not related to C++ at all. At this point, you're getting really.
This is not really in-depth stuff.
Here is how my target works.
The machine pass pipeline. We're now like really deep inside the compiler, where normal folks will never go. And chapter 13, the machine pass pipeline. Now we have basically the representation, and where does this pipeline go?
So that pipeline. So again, the pipeline is the sequence of optimization that you run for your in your compiler, and specifically the machine pass pipeline is there is an example here. Is what are the different optimization that the backend goes through to get all the way to assembly, and to I guess make it kind of high level. The idea is that LLVM uses an intermediate representation called static single assignment. So something that you don't need to know how it works, but essentially that's. It allows you to, for example, if you have a machine that has 10 targets, you can have 10 targets, and then you have 10 assembler. So 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 you have 10 assemb that's a way to represent the program that make it more amendable to optimization. It's easier to prove things on that representation, but that representation comes with, I would say, quirks that are incompatible with hardware constraint. So you have to get rid of that of that representation, and that's what the machine pass pipeline does. It's putting it really in the linear sequence of code that you wouldn't see when you print your assembly code, and also assign the registers to all your variables. Like when you're writing C++, I'm hoping that you're not worrying about how many registers you're using and things like that. Well, you could, but hopefully you're not optimizing on the register allocation by hand, and that's what this pass does. It's okay. Here that many variables are used, and you put them in registers and stuff like that, and that at the end produces your assembly code.
And that brings us to the fourth part of the book, which then is actually about, like, the final part of the journey of the becoming assembler from the compiler, right?
No, actually, so that part is a little bit tricky, as in, like, if you remember, there is the middle end, then there's the backend, and in the middle there is this thing that is called instruction selection, which is the thing that's responsible for taking the LLVM IR, which is somewhat target agnostic, and translating it into machine IR. So the reason that I cover that, I guess, later is that piece is kind of the heart of the backend, and it wouldn't have made sense to talk about it before we explain all the subtlety of the machine IR, because essentially you are, as a backend engineer, you have to produce the machine IR yourself from the LLVM
of these parts. So you're getting started here again with the introduction selection in chapter 14.
Exactly.
And then you go deeper into introduction.
Just getting started. Yeah. So essentially, again, this is really the beating heart of the backend, and that part is so complex that it's actually broken down in different phases. So it's still part of the same optimization per se, but there's different phases. And for instance, if you look at chapter 16, the legalization phase, like, think about your C++ program when you do A times B, for instance. It's possible that actually let's say you're using double precision floating point, and when you do A times B, it's actually possible that the processor that you're running on doesn't support double precision arithmetic. So the responsibility of the legalization phase is, okay, the program wants to do this multiplication for a type that I don't know how to do. How do I make sure that it's still possible to run on my target? And that's where things like call to libm or things like that will be automatically inserted, or clearer things where, it's like you're doing a power, and we know that in that case it's okay to replace power by a multiplication if you support that. So but there's a bunch of things that you need to do to essentially take whatever crazy thing as a developer you can write and make it map on the actual hardware. The hardware is much more constrained than whatever C++ exposed to you.
And then the book goes in its fifth part into the final lowering and optimization.
Yeah. So that I would say,
like 18th chapter.
Yeah. So those are more, I would say, it's mandatory steps in your lowering phase, because like you have to produce a linear sequence of instructions to produce your assembly. So you have to schedule the instructions. And you have to, then chapter 19, register allocation, you have to allocate your register, otherwise the hardware will have no idea how to pull the variables and all that stuff. And same thing with chapter 20,
now
you
we're
have to lay out the stack.
Right? And
exactly.
chapter 20.
So all those things come.
The stack layout.
Yeah. So all those things come pre-existing in LLVM, but you still have to configure it to do the right thing for your target. So that's what I'm explaining in those chapters. And then chapter 21 is really like just the cherry on top. Like if you're not content with producing assembly strings, I teach you how to actually produce the binary code. So it's very lightweight in the sense that it's only showing the ropes, because you could write a whole book about binary tools. And like you saw, Jensen, the book is quite big already.
Yeah. It covers the whole journey, which is nice.
Absolutely.
So
yes.
let me go to the first page, and we are now through with the overview on the book. And so let's get started with the interview.